Hello everyone and welcome to this video which explains the connection component of an Ethernet LAN. Overview. In the previous video, we saw the components of an Ethernet LAN and standards that govern its architecture. Now it is important to understand the connection component of an Ethernet LAN. This video will describe the connection component of an Ethernet LAN, including network interface cards and cable. Ethernet network interface card. NIC. A NIC is a printed circuit board that provides network communication capabilities to and from a PC on a network. The Ethernet NIC is also called a LAN adapter, and the NIC constitutes computer interface with the LAN. Historically, the NIC plugs into a motherboard and provides a port for connecting to the network. Today, computers have a NIC that is integrated on the motherboard. The NIC communicates with the network through a serial connection and with the computer through a parallel connection. When a NIC is installed in a computer, it requires an interrupt request line RQ, an input-output address, a memory space within the operating system, and the driver that allow it to perform its function. An IRQ is a signal that informs a CPU that an event that needs its attention has occurred. An IRQ is sent over a hardware line to the microprocessor. An example of an interrupt request being issued is when a key is pressed on a keyboard and the CPU must move the character from the keyboard to the RAM. An input-output address is a location in memory that is used by an auxiliary device to enter data into a retrieve data from a computer. Also, a NIC is a layer 1 and a layer 2 device. It provides physical access to a network medium and layer 2 addressing by using MAC address. The MAC address is bound onto each NIC by the manufacturer, providing a unique physical network address. Let us see Ethernet media requirements. There are a number of different cabling types that a network engineer or administrator sees over the course of their career. New individuals coming in the field have to be familiar with a number of different cables and connectors to be prepared for their day-to-day activities. The following cabling media type will be most commonly seen in Ethernet LAN environment. The first is twist pair cables. There are two types of twist pair cables: unshielded twisted pair (UTP) and shielded twist pair. The most common type of cables is unshielded twist pair. As the name suggests, this type of cable includes an unshielded media that includes twisted pair. Specifically, UTP includes 4 different pairs of copper cables that are each twisted together. The twisted rate depends on the specific category of cable. Most networks in the last 15 years or so have included UTP cabling that is at least rated as category 5. This cabling supports Ethernet data rates up to 100 megabytes per second on modem networks that have been deployed recently. It is common to install at least a category 6 cable with support for up to 1000 megabytes per second and a Cat 6A up to 10 gigabytes per second Ethernet. Another type of twist pair cabling includes a shielded that is used to both contain and protect different twist pairs from interference. This type of cabling is not commonly in modem LAN network deployment. However, some newer very-speed Ethernet technology may require a cable that has a shielded. The term shielded twist pair can include a number of different cable types which all include a shielding mechanism. Some cable types include a shielded only between the different twist pair within the cable, and other include various shielding types both around the pair and the whole cable. Ethernet cable category. The CAT in CAT 5 and CAT 6 etc. is short for category. Network cables are divided into categories based mainly on bandwidth, maximum data rate, and shielding. The CAT Cat6 in Cat5 or Cat6, etc. is short for category. Network cables are divided into categories based mainly on bandwidth, maximum data rate, and shielding. Bandwidth or frequency is a property of a cable and measures the rate at which a signal will cycle each second. 1 MHz is equal to 1 million cycles per second. Cat5 can handle up to 100 million signals a second. The cable category with the highest bandwidth is currently Cat8 with 2 billion signals per second, 20 times as many as Cat5. About data rate and bandwidth, data rate and bandwidth are related terms, but they are not the same. Higher frequencies carry more ones and zeros, allowing more bits of data to be transmitted per second. Cat5 cables have a 1-to-1 relationship between bandwidth and data rate. 100 megabit per second cable can transmit 100 megabit per second. Higher category cables such as Cat8 encode the data so more bits can be transmitted with the same amount of time. Frequency can be increased by increasing the gauge of the conductor wires, adding more twists to the conductors, or adding shielding to each pair of conductors. Shielding. Some Ethernet cables are shielded to prevent the cable's conductors from electromagnetic interference caused by the power lines, large machinery, and fluorescent lightning. Shielding also prevents parallel conductors inside the cable's jacket from interacting with one another. About the cable length. The maximum length of an Ethernet cable is about 90 meters. Good quality cable with shielding and thicker conductors can reach further, but some trial and error will be required. Keep in mind that cable lines are rarely straight, so plan on extra cable for some twists and turns. The second type of cable is optical fiber cable. A very common type of fiber connection is multimode fiber (MMF). This type of cable uses light to transmit signals between devices and is thus not susceptible to electrical interference. MMF cables use a large internal core diameter and can utilize lower cost lead for transmission. This is both an advantage and a disadvantage. While the larger core diameter offers a cable that supports multiple modes and a cable that is easier to work with, it also limited by the same factors in terms of total usable cable length. MMF cables are typically only used for connections that are less than 2 kilometers in length. This also makes it a very common cable in LAN deployment. Like MMF, single mode fibers SMF transmit signals via light and is not subject to electrical interference. The difference between SMF and MMF is in the physical characteristics. A MMF cable has a large core diameter and is able to accept a number of different modes that come into the cable from multiple angles, while SMF has a much smaller core diameters and accepts signals coming in from a specific angle and on a specific mode. SMF can be used for cables runs of very long distances, typically up to 40 miles without repeaters, depending on wavelength. Connectors. The first connector is registered jack 45 connector, RG45. The cable connector that is found on almost all UTP and STP cables is a registered jack 45, which is mostly commonly referred to as RG45. If you look at RG45 transparent end connector, you will see 8 colored wires twisted into 4 pairs. 4 of the wires 1 and 2, are used to transmit data from the computer, while wires 3 and 6 are used to receive information on the computer. You will also notice that the transmit pin on the computer is connected to the receive pin on the switch via wires 1 and 2. This is important because we want to make sure that data that is sent from the computer is received at the network switch. We also want to make sure that data that is sent from switch is received at the computer. So you will notice that transmit pins on the switch are connected to the receive pins on the computer through wires 3 and 6. RG45 jack. The jack is the female component in a network device, wall, cubicle, partition, outlet, or patch panel. As you look look at the female connector from the front, the pin locations are numbered from 1 on the left to 8 on the right. Let us see now Ethernet fiber connector. The straight tip AC connector is often seen on the end of multi-mode cable. It has been commonly seen along with the SC connector for the last 2 years, but is being slowly replaced by multi-fiber connector. The second is subscriber connector AC. The subscriber connector can be seen commonly on mid-mode fiber or single-mode fiber. As with SC connectors, the ST connector is slowly being replaced by multi-fiber connector. The third is the recent connector. The recent connector was developed for high-density deployment where multiple fiber would be terminated within a confined space. Unlike the SC and ST connectors, the LC connector is always duplex connecting a pair of fiber at a time. The fourth is the multi-fiber push-on MPO connector is another duplex connector that offers an easy option for connection. As the name suggests, it was designated to be able to be connected multiple times without the creation of any potential connector issue. It is often also referred to a fiber termination push-on. Cisco Fiber-optic small form factor pluggable. The industry standard Cisco small form factor pluggable gigabit interface converter is a hot swappable input-output device that plugs into gigabit Ethernet port on slot, linking the port with the network. SFP can be used and interchanged on a wide variety of Cisco products and can be intermixed on a port-by-port basis in a combination of 1000 base D, 1000 base SX, 1000 base LH, 1000 base EX, and base ZX. Cisco Fiber-optic, SFP single mode, and SFP multi-mode. SFP transceiver that operate over fiber optic can also be categorized into different types based on their fiber type. Among them, there are single mode and multi-mode modules, as well as simplex and duplex SFP modules. These SFP modules are categorized into single mode working into single mode SFP working with single mode fiber and multi-mode SFP working with the multi-mode fiber. Duplex SFP with dual fiber port and simplex SFP with single fiber port. Apart from the above mentioned SFP transceiver, which use two fibers from duplex transmission, there are also SFP transceivers which only use one fiber for transmission. It is a simplex SFP module, or more commonly known as bidirectional SFP, which are equipped with WDM couplers duplexers. The most frequently used BDSFP wavelength pairs are 1310 nanometers / 1530 nanometers, 1310 nanometers / 1490 nanometers, and 1510 nanometers / 1590 nanometers. And the transmission distances vary from 10 kilometers to 160 kilometers depending on the wavelength used. It is very easy to distinguish a simple SFP module from a duplex SFP module. All SFP transceivers must be used in pair. Duplex SFP modules on both sides must be of the same wavelength. However, for a simplex BDSFP, it is necessary to use two having opposite wavelengths for the transmitter and the receiver. UTP implementation. In addition to the current UTP category of cable that is used to connect devices, it is important to select the correct wiring of pins in the RG45 connectors as well. We need to determine which of the cable to use for straight-through cable and crossover cable. In straight-through cable, the RG45 connectors on both ends of the cable show all the wires in the same order. If the two RG45 44 ends of a cable are held side by side in the same orientation, the colored wires will be seen at each connector end. If the order of the colored wires is the same at each end, the cable type is straight-through. With the crossover cable, the RG45 connector on both ends show that some of the wires on one side of the cable are crossed to a different pin on the other side of the cable. Specifically, for Ethernet, pin 1 at one RG45 end should be connected to pin 3 at the other end. Pin 2 at one end should be connected to pin 6 at the other end. Although only 4 of the wires are used to send and receive data in most environments today, some of the newer standards use all 8 wires. Therefore, it is important to know the order of all 8 wires in a UTP cable. There are 2 popular wiring standards today, 568A and 568B. If the goal is to create a straight-through cable, you would use the same wiring standard on each end, for example 568B. But if we want to create a crossover cable, you would configure one end of the cable using the 560A wiring scheme, while the other end is set up using the 568B wiring scheme. Let us see straight-through and crossover cable. Use straight-through Ethernet cable for the following cabling. Straight-through cable is used for switch to router, switch to PC or server, and hub to PC or server. Use the crossover cable for the following cabling: switch to switch, switch to hub, router to router, PC to PC, router Ethernet to PC NIC. This is the end of the video. Thank you for watching. If you are interested, subscribe and give your comment.